Hello everyone, myself Manikumar Uppala of CSIT C section, studying in Institute of Aeronautical Engineering. Today's my Tech Talk topic in network web security is catchy cookies for browser authentication. Catchy cookies, the hidden key to browser authentication. This presentation will explore catchy cookies, a powerful new mechanism for secure browser authentication. We will delve into the technology behind catchy cookies, explore the security benefits, and discuss best practices for implementation, understanding browser catchy versus traditional cookies. Browser catchy stores temporary files like images, scripts, and style sheets for faster page loading. Cannot be used for authentication and primarily focuses on performance. And let's go to traditional cookies. Small text files sent by servers to store user data in the browser, often used for session management and authentication vulnerable to attack the and privacy concerns. It means the browser cache means it's a small type of memory where it gives the fastest performance to the user, and it means cache means the web the website stores the data, and whenever the user asks for the data it immediately gives as soon as possible, so it is called cache. And whenever where the cookies are the text files sent by the servers, it means the servers will send the text files, and it have many advantages and disadvantages. It means some websites may attack the user devices with the cookies, so don't allow cookies if it is not necessary. And the evaluation of web authentication methods. Passwords simple and common but prone to theft and brute force attacks. Two-factor authentication adds a second factor like SMS codes, but can be inconvenient and vulnerable to phishing. Biometrics uses unique biological traits like fingerprints and facial recognition, but can raise privacy concerns. Catchy cookies offer strong security with minimal user interaction and privacy considerations. How catchy cookie work? Technical deep dive. Server side setup, browser side validation, and where server side setup. The server stores a unique identifier nonce for each user. This identifier is included in the initial response setting a catchy cookie in the browser. Browser side validation. When the user makes sequent request, the browser sends the catchy cookie. The server verifies the nonce to validate the user's identity. It means the catch cookies working is like there is a server side setup and browser side setup validation, and whenever the server stores a unique identifier for each user, the browser side will validate the user's nonce identity to move on. Security benefits: resistance to farming attacks. Malicious actors redirect users to fake websites, stealing credentials. Cache cookies prevent this by verifying the server directly. It means the user when the user search for a website, it will be cloned to it will be goes to clone DNS, and there we get a malicious address where the user seems to be same website as he want to log in, and he will enter the original details and tries to log in, but the malicious server will says that the details are not valid. But here what we are doing is we are entering into the fake websites and we are directly entering the original details so that the hackers or the attackers can get the credentials of the website directly. And secure communication. Cache cookies ensure that the communication between the browser and server remains secure, reducing risk of man in the middle attacks. Privacy implications and risk mitigations. Privacy concern. Cache cookies store user data locally, raising privacy concerns. Proper storage and access control mechanisms are crucial. And mitigation strategies. Use strong encryption, limited data storage, and clear user consent policies to mitigate privacy risks. Implementation strategies for developers. Leverage browser APIs like IndexedDB to store cache cookies securely. Implement server-side logic for generating and verifying nonces. Ensuring secure communication. It means the generating and verifying nonces means the every user has this separate identification or identity nonce called it is called nonce, and whenever the generating and verifying nonces are making the ensuring secure communication between browser and the server so that the credentials or the data will be safe when the nonce are verified. And apply best practices for encryption and access control to protect user data. Best practices for cache cookie management. Use strong encryption algorithms to protect sensitive data stored in cache cookie. Limit the amount of data stored in cache cookies to minimize privacy risk. Avoid storing unnecessary information. Set appropriate expiration times for cache cookies to ensure data freshness and limit storage duration. Implement robust security measures such as access control lists and data validation to prevent unauthorized access. So here, use storage encryption algorithms to protect sensitive data stored in cache cookies. So here we should not store the cache cookies as long as possible, because when we left the browser the cache cookies little bit remain same whenever we open the website, same website. So here the other websites may have malicious attacks for these cache cookies, and these cache cookies may contain some credentials or data where the data may be hacked by the attackers. So use strong encryption algorithms to prevent sensitive data, and limit the amount of data stored in cache cookies to minimize privacy risk. It means we have to set an amount of limit for data storing in the cache cookies. Means when the cache cookies store the data should be only in the certain limit of the amount. Like it should not store the large amount of data, because if it stores, the device may be lagging, or the performance will be very low when the cache cookie stores the high data. So avoid storing unnecessary information in cache cookies. Implement robust security measures such as access control list, and data validation to prevent unauthorized access. It means we have to implement a robust security measures for controlling the list of data or cache cookies and management that validation data to prevent unauthorized access. It should not access any of the data from the cache cookies to other websites. Now let's go on to case studies, real world applications. E-commerce. Online retailers use catchy cookies to authenticate users and improve checkout speed, enhancing customer experience. Financial services. Banks and financial institutions use catchy cookies for secure logins and online transactions, protecting sensitive financial information. Social media. Social media platforms utilize cache cookies for seamless user logins and personalized login content delivery. So, in e-commerce, a type of cookie stored by a website on a user's device that helps improve loading speed performance by temporarily storing static website elements like images, CSS, and JavaScript within the browser's cache. And cache cookies in financial services are cleared immediately because clearing your cache and cookies can help with login issues and improve your browser's performance. And cache cookies in social media. It stores the temporary storage of small data files called cookies by your browser, which holds information about your interactions on a social media site like login status, preferences, and viewed content, allowing for faster loading times and more personalized experience when you revisit the platform or the website. Essentially, it's a way for a website to remember your details without needing to re-ask every particular item next time. Future of cache cookies and web authentication. Cache cookies are expected to become more widespread, leading to a future or more secure and efficient web authentication. As the technology evolves, expect even stronger privacy guarantees and broader adoption across various web applications. Thank you. This is Manikumar Uppala.